Alright, Chapter 3, Section 5. Technically it's titled Finding the Equation of a Line, so I included that in the title. But really it should be the point-slope form in my opinion. We're looking at the third and final different equation for a line that we're going to do this chapter. And this one here, technically it's the point-slope theorem. It's derived, it's actually a variation of slope-intercept of y equals mx plus b. But this new one, I'll put it in red for dramatic emphasis. Worth memorizing. It's going to be on your test at least if you're in one of my classes. I'm going to ask you to know this thing from memory. And this one here, so y minus y1 equals m parentheses x minus x1. And with that maybe I should mention that m is the slope. And if you think back to pretty much every equation that we've been using, x and y are the variables. So then the point then is going to be the x1 comma y1. So the number that's after the y variable is the y value of the point. The number that's after the x variable is the x value of the point. But you'll notice we're going to talk about this the minus signs in there, how that changes things. But what are these good for? Works well when you know one of two different things. Either a point and the slope, which kind of seems obvious with the title. So point and the slope. So right now we're trying to hunt a woodchuck in my backyard that's been getting into my wife's garden. So you could say, well, if you earn $5 for trying plus $7 for every woodchuck that you catch, you know a point. You have, I guess would fit the other one too, but 0 woodchucks gets you $5, so it'd be 0.5 would be your point, but then the slope would be 7. The amount you get per woodchuck. Should have thought that one through, so I just thrown it out there. The other one though is going to be 2 points, because if you know 2 points, you can slap them into the point or the slope equation you've been using for years, and then you now know a point and the slope. You just pick which one of the 2 points you want to use. Okay, moving on. I'm going to actually go through and do some examples with this. What I would encourage you to do, strongly encourage you to do, as you do these problems, to keep from having to try to memorize the equation the night before a test, being all stressed out about it, go through and actually just write out the equation without any numbers in there as you do the problems. Makes the problem a whole lot easier, and then you're a lot more likely to know it when it comes test time and not have to worry about trying to memorize it the night before. But when we have the equation, so y minus y1 equals mx minus x1, the slope is always our m value, so you could just take and throw a 5 in the m place. I'm going to write it right below there. Now my x values, or my point, is my x1 comma y1. So when I write out my equation, I just copy down my parentheses and my x and my minus, but now we have this minus x1. x1 is a negative 2. So really we have x minus a negative 2. If you write it that way, it's not simplified. Minus a negative is always basically the same as plus a positive. So to actually go through and write this correctly, it's just going to be x plus 2. So that'd be the simplified version, because we have x minus negative 2 turns into an x plus 2. Y, on the other hand, we have y minus y1. y1 is a positive 3, so it just turns into y minus 3. Something you could notice here is that when you have a negative 2 for the x value, it shows up as a positive 2. When you have a positive 3 for the y, it shows up as a negative 3 in the equation. Some people over the years have just remembered it as though math is stupid. It's always the opposite sign from what it is. But really the reason is that you're subtracting the x value, so it changes the sign. But the sign in the equation will always be the opposite of the sign of the point. Okay, let's do the same thing again. So if I now have my point being negative 3, 4, and 1, negative 4, I'm going to have my y minus y1 equals m x minus x1. And it really doesn't matter which one you use for your point. I'm maybe just going to go with this first one. I'll call this x1 and y1. Then I could take and slap those things in there. So I have x minus a negative 3. X minus negative 3 is going to turn into an x plus 3. And y minus my y value, so y minus 4. And I'll actually do it both ways, why not? You could just as well have had a y plus 4 using this second point over here, the 1 negative 4, and x minus 1. So either equation would give you the exact same line. But now the only thing we need to fill in still is the m, is the slope. So I'll maybe call this x2 and y2. Then if we wanted to get the slope, if we go back to our slope equation, m is y2 minus y1 over x2 minus x1. And I don't think we've done slope this year before this point, so maybe make this comment. If people screw up on slope, it's that they do the big number minus the small number. It doesn't matter which point you start with, but you always have to start with that point. So if you're doing this y value minus that y value, so negative 4 minus 4, then you have to do this x value, the x value from the same point. In this case, we're calling it x2 minus a negative 3. So that's going to give me a negative 8 divided by 1 minus negative 3 is 1 plus 3, 4. So my slope then is a negative 2. And put that in both of my equations. I expect you would just pick one of those two equations. My next examples are going to do that same thing, but kind of the opposite way. So I'm calling it Roman numeral 3, finding slope and point from an equation. So in this case now I give you the equation and I'm asking you to find the point and the slope. Just like before, especially if you're beginning and you're feeling a little uncomfortable with this, write the equation directly below. If you line up the different parts, it makes it a whole lot easier. I still can remember being in Algebra 2 when I was in high school and having a quiz with this equation on it, and I would have swore I'd never seen it before. But okay, so if you take and line the points up, then from there you could just say, well, I know my point is going to be x1, y1. So you can go through and say, well, where are my points? And I made this first one a little bit easier for you because the x's line up here, the minuses line up there. So then my x1 has to be a 7. I kind of killed it by writing over the top, but so that's 7. Now my y's line up here, my minuses line up, so y1 has to be a positive 5. And again, like I said before, you could just look at it as though it's always the opposite sign as what's in the equation. So when the equation says x minus 7, right here your minus is going to end up being a positive, and so on. The slope then is my m value, so slope just has to be 3. So maybe I'll write that in blue. So m for slope equals 3. The next equation, I'll just write it out in blue. So y minus y1 equals m x minus x1. And here we have a little bit of the plus negative issue, or positive negative issue. So my point then, my x1, y1, the x isn't the number on the left. That's a mistake people make. It's the number that's paired with the x. So I have my x's, I have my minuses, so x1 has to be a positive 1. Where it's at x minus 1, we get a positive. Now here we have a y. Now I have a plus in this equation, a minus in this equation. So what you have to do is you have to look at this plus as though that really is y minus a negative 4. So now I could say I have my y's lining up. I have my minuses lining up. My y1 has to be a negative 4. That's kind of mathematically how you get it, or you could stick with the comment before about how if it says plus, math is stupid, you know, it's always going to be the minus. The slope then, the slope is the m value, and that's going to be 2/3. So that's finding the slope and the point from an equation. The last thing I want to do, and I use those same two equations, is going to be to graph them. So in this one I'll just write the points again. So my point is 7, 5, and the slope is 3. For this, really it's the same thing as the hints I gave on graphing the slope-intercept form, the y equals mx plus b, is that really just find your starting point, so dot on the point, and then use slope to find points, and connect them. Okay, so I have this 7, 5 for this point, so I'm going to be over 7, up 1, 2, 3, 4, 5. So that's my point. My slope is 3, so I'm really kind of close to the end. So 1, 2, 3. Oh, you could say slope 3 over 1. So rise is up 3 over 1, so it puts me right there in the corner. That's going to be the same as negative 3 over negative 1. So I could also go down 3 and left 1. Down 3, left 1, down 3, left 1, down 3, left 1. So once I get those, I can take and get a nice line that covers my whole graph, and make sure to put an arrow on both sides. So I'm going to extend down a little bit further, and that'd be one of them. If we want to do the same thing for the second line here, we could say, well, the point, the x value, it's x minus 1, so it's going to be a positive 1. The y value, it's y plus 4, so it'll be a negative 4. And the slope is 2/3, that's my rise over run. So over 1, down 4, 1, 2, scroll down a little bit on the page. There we go. So over 1, down 4, 1, 2, 3, 4. Now when I do my slope, my rise is 2, run is 3. Rise of 2, run of 3. Do that same thing backwards, so I'm going to drop 2 and then go 3 to the left. Drop 2, 1, 2, 3 to the left. And now put a nice line through those. Yeah, stick with that. Make sure the line covers the whole graph so I can give you full credit. Goes through those points nicely. Throw an arrowhead on either side. And that's all I had for this section. So that's point-slope form.